Hello, in this video tutorial I want to give an overview of the typical workflow I use with the scenProc tool to make Autogen based from OpenStreetMap data. In this tutorial I'll be showing the configuration file I've used to create Autogen for part of the Netherlands, and I'll just walk through all of the steps and explain you why I put them there and what they are doing. Let me start by saying that this is just my workflow, but the tool is quite flexible, so you're free to use it in another way. And it also largely depends on the kind of attributes that your data has. The more attributes, the more interesting things you can probably do. So don't take this as a 100% fixed workflow that you should use, but use it as some inspiration of what you could do with the tool. Good, let's get started. We'll just walk through each of the lines. The first line is the import OSM, import OpenStreetMap data line, where I just point to the file I want to load. I don't want to limit the coordinates, so I just put a star there. And these are the three kinds of attributes, kind of feature types I'm interested in. Highway for everything related to roads, land use for the land use information, and building polygons. The next step that I use is that I export everything to Shapefile again. I usually do this so that I can see if the data was imported correctly and that I can load it in the GIS tool, as I've done here, for example. We'll come back to this later, but here I've loaded some of the data into a GIS tool so that I can analyze it and see how I can make best use of it. Then the next step is the split grid step, where we are going to split all the features into the grid with the size needed for Autogen, AGN. And we have an extra attribute here. This one is optional, but you can specify which objects you don't want to be split. And in this case I've specified all the buildings there. So all features which have a building attribute with any possible value. What this means is that if a building crosses the line between two Autogen tiles, it will not be split into two buildings, but it will just be put into the tile where the center of the footprint is. For buildings this gives much more realistic results, because you might end up with a lot of small buildings because they are chopped. And it also is good for the performance. Then the next things I do is some sort of pre-processing of the data. I'm going to add some attributes to it that I can later on use to construct the Autogen buildings more easily. And I'm going to add two types of attributes. One is for the sort of category of the building, and one is for the type of the building. We'll start with that first one. I've added some comments for myself here to explain the possible values again. But basically I'm going to create 5 different types of buildings. The first type is just rectangular, almost rectangular, regular shaped buildings, convex and concave polygons. And each of them is done with a line here below to add an attribute. And let's just take the first one. So we have an add attribute, and the attribute I'm going to add is called build type, from building type. And I wanted to give it the value of 1, which is the rectangle. And this one here means that the value should be unique. So if it already has a build type attribute, it will be overwritten. And the most interesting part is the filter here. What I say is I want all feature type is polygon, so I want all polygons that are a building which have exactly 4 vertices, and I want it to have 4 perpendicular angles. So that means all the angles of the building are 90 degrees or almost 90 degrees. There's in the options you can set the tolerance for that. So 4 vertices and 4 angles of 90 degrees, which means it must be a rectangle. Then for the second one, almost rectangular, what I do is I say I shouldn't have assigned building type 1 already, because then it's a rectangle. So I want to skip all those that match the first case. Then I'll take all the polygons that are building again, and this time I'll say I want the area ratio to be bigger than 70%. And the area ratio is the difference between the area of my polygon and the area of the rectangle that fits around it. So if this difference is relatively small, then it's almost a rectangle. Maybe there's like a small extension onto the house of a tiny little bit. So I say all of those I'll just treat them as rectangles as well. I accept the small difference. And then for the third one, which is the regular shaped. With regular shaped, I mean objects that have a lot of parallel edges. So that's maybe L-shaped building or that kind of buildings, which can be split into multiple rectangles. So here I say again, it shouldn't be building type 1 or 2, because that's what I assigned above. And then I want all polygons that are a building which has more than 3 perpendicular angles, so at least 4. So that means that the building should be relatively rectangular in shape. And I want it to have less than 2 edges that are not parallel to some other edge. And I want it to have less than 10 vertices, because else you often get very complex buildings. And those I give a value of 3. Then for the other one, convex, we say anything that's not type 1, 2 or 3, which is a polygon, is a building, and which is convex. I give it a value of 4. And then the value of 5 is basically just anything else. It's a building that's not type 1, 2, 3 or 4, but it's still a polygon and a building. Then I give it 5. So that's the remaining buildings. And that gives me 5 types of buildings I can use later on. And when we create the Autogen buildings, you'll see how we do that. Then the next attribute we want to add is a building category. Before I explain that further, let me first jump to the GIS tool, and I'll explain a little bit. Let me turn off some layers. What you see here in different colors are the land use values that can be found in the OpenStreetMap data for this island. It's the island of Texel in the Netherlands. And the ones that we're most interested in is this green one here, forest. We will use those polygons to create the forest later on. But we also have, and I'll zoom into this town here in the middle, we have this bluish one here, which is the bottom one, residential. And we see there the magenta, the purple one, which is industrial, and you see some examples of it here. So what I want to do for the building category, that I will check if a footprint is in an industrial or in a residential polygon, so that I know what kind of building it is. And that is what we're doing here. So I have defined 3 categories here, rural, residential and industrial. And basically with rural I mean anything that's not within a town or not within an industrial zone. So that can be a farm or a house somewhere in the middle of the countryside. So what we do here is I first add and make all the buildings type 1 rural. So I say all of them get a value of 1 for building category. All the polygons that are buildings. Then I say add attribute if inside. So then I say I want to add an attribute to all polygonal buildings that are inside this filter. So that's the second filter. And that's all polygons with land use is residential. Then I give them building category 2. And then last we do the same, all the buildings again, and we say if they're inside industrial, we give them category 3. I put it in this order because you might have seen that in the GIS tool. The industrial polygons can be covered by bigger residential polygons of the town. So therefore I do the industrial check last, so that I'm sure that that one is not overwritten later on. So then we have a building category and a building type. Then what I do next in my configuration file is that I will replace some polygon footprints of buildings by rectangles. This is what I explained here before for the regular shaped buildings. So that's building category 3. I can show an example. Let me go back to the GIS tool. If I, for example, zoom in like on a building like this, which is an L-shaped building, or this kind of building, that could well be represented by 2 rectangles, or even this kind of building which has a small extension. that can be represented by two rectangles. So what this step does is that it replaces those bigger complex polygons by a number of rectangles, and I want to do that for all buildings that are type 3. Then here we have another processing step where we're going to add some extra features, but before I explain that, let me jump back to the GIS tool. What we're going to do here is that we're going to put some lights along the road, and that's just an example of how you could put point features along a line feature. So here I've loaded a set of the roads on the island, and the one here in red is sort of the main road. It goes from the ferry to the island, like to the main cities and then onto another village. Along that road, which is a secondary road in the OpenStreetMap data, I want to place point features that I can use to create light poles in the Autogen. So we have a place points along line processing step, and I select all lines that are highway of type secondary. Then the next argument is the distance between the points. So I want to create a point for every 150 meters. I also give them an offset of 5 meters from the center line of the road. We don't want our light poles to stand in the middle of the road, so we move them to the side of the road. Then the next two attributes are the new attributes that will be added. So I give it an attribute with the name type, and I give it a value of light. That's the Dutch word for light. This allows me to later select them and use them to create the Autogen lights. And the last argument is the attribute into which the heading will be stored. This step calculates the heading that the light should have so that it aligns with the road, with the line that it's created from. So that's the last step, sort of, where we are still preparing the data. Now it's time to start making the actual Autogen. So let me scroll down a little bit. What we first do is we set the Autogen height. In this case, because it's an island, not densely populated, I just only use the lowest class, so with 1 or 2 story buildings. I don't use the taller buildings in this one. And I set a custom texture for my buildings so that texture is used. And then we can start creating the Autogen objects. First, I create the forest. So I select all the polygons that have land use is forest, and I give them I assign the GUID of the mixed forest class from the Autogen. Next, we'll create some buildings, and here I have 4 different steps to do that. First, I create buildings for all buildings that are of building category 1, which is the rural category, and I only do it for building types smaller or equal to 3. So 1, 2, and 3. And if I scroll up, that's the rectangular, almost rectangular, and the ones that we replaced with rectangles. So those can be represented well with the Autogen buildings. The types 4 and 5, the more complex shapes, we are not using at the moment. I'm still experimenting if I can use the polygonal Autogen buildings for them, or maybe I will create custom MDL objects based on the footprint. So we're ignoring these at the moment. So for all those building type 1, 2, and 3 and building category 1, I just use gabled roofed buildings. Then if we go to building type 2, which is the residential, I want to do, once again, I only do it for types 1, 2, and 3. And if the width of the building is smaller than 20 meters, I will use a gabled roof. So that's not too big buildings, which is most likely just normal houses. And here we have an additional attribute of max ratio. That means if you have a not so wide but quite long building, it will be split into a number of different Autogen buildings. For example, if you have a footprint of a row of houses, which is maybe 100 meters long but only 10 meters wide, then it looks better if you split it up into a number of Autogen buildings. So that's what this does. And all of the buildings that are also in the residential category but have a width bigger than 20, I just use flat roofs for them. Because most likely those are the bigger buildings in a residential area, like a school or a shopping center. So they will look better usually if they're represented by flat roofs. And then all the buildings that are in category 3, industrial, and once again types 1, 2 and 3, I also give flat roofs, because industrial zones is usually more like warehouses, small factories or office buildings, which typically have flat roofs. So it will look better if I give them flat roof. Then the next kind of Autogen objects I'm creating, it's also the last one, is the library objects. Here I select all point features with an attribute type which is equal to light, and as you might remember, that's the attribute we used up here for the new point features we created for our light poles. And that one I have assigned the grid of the urban street light from the default FSX Autogen. I specify that the heading is stored in an attribute called heading, HDG, and the last argument is the size of the object. And if you hover here over the grid, you'll see that it's specified in the command there as well. It's 8 by 8 meters. So I've entered that here so that the right Autogen shape is created for me. The OpenStreetMap data contains a lot of point features as well. So it could be interesting to see if also traffic lights and those kind of objects can be created as library objects and put into the Autogen, but I'm not doing that here in this example. And then the last step is to write all those Autogen files to disk. I select which version of Flight Simulator I want, FSX or FS 2004, and I select the folder, the texture folder of my scenery where they should be created. And then we can just press run. And this will take a little while, around a minute I think. But I'll try to explain a little bit what you can see on the way. So you see, while it's busy with processing the data, you get some feedback already. It has been reading the OpenStreetMap data and it's imported around 15,000 features. So all those different lines, polygons, buildings, etc. And now it's busy splitting them into the Autogen grid, and once it's done, you'll get some feedback like on how many different tiles it has created, etc. You see it's here, it's 161 cells. And also when we're adding the attributes, you can see that there are like 5,000 rectangular buildings, another 750 that are almost rectangular. And so you get some feedback while it's processing, and that can be useful to see if things go well. If you expect to find some features, but the tool reports that it found 0 features, then you know that maybe your filter is wrong or something else is wrong in your data. And while I'm talking, you see that it's proceeding, reporting how much of each building type and building category it has found. You can see there are like almost 7,500 buildings. The other feedback jumped through. Let me scroll up. There are almost 7,500 buildings, of which almost 3,000 are within the residential category and 100 are industrial buildings. So you'll find all kind of useful feedback in there. Also how many Autogen objects have been created, and then here the different files have been written, 137 files. And at the end it will show you how long it roughly took to do all this. Well, then of course you're eager to see what the end result is. Because loading Flight Simulator takes some time, I already started it up before with the Autogen we just created. And here you're looking at that town at the center of the island, and you see the different houses and the different trees. And this is also the sort of main road. And if I go down a little bit, you can see that there's the light poles that are placed along the road. They follow the curves of the road quite well. So if I go up a little bit here, you might remember that the industrial zones were more at the edge of the town, and you see there are some flat buildings there. Some of the others are not represented, but that's then because these are the more complex buildings that can't be represented with rectangular Autogen as well. And here on this edge of the island you see that there's a lot of forest with all the houses, probably a lot of holiday houses on this island in between. So I hope this tutorial gave an overview of how you can use the tool to create Autogen and what kind of Autogen you can make. Like I said in the beginning, there's not one fixed workflow that you have to follow. Use your imagination, use the attributes available in your data, and if you have questions or suggestions, or if you need maybe other features to filter in a specific way, just post on the forum and have fun creating your Autogen.